Your brain is shrinking right now. Every single day you continue certain habits, you're accelerating cognitive decline at a rate that would shock you. Scientists have discovered that specific behaviors can increase your dementia risk by over 60%. And the scariest part is that millions of people do these things without realizing the permanent damage being done to their brain cells. A groundbreaking study published in the Lancet followed over 800,000 participants across multiple decades and found that preventable lifestyle factors account for nearly 40% of all dementia cases worldwide. That means 4 out of 10 people suffering from memory loss, confusion, and the inability to recognize their own family could have avoided it entirely. Right now, as you're reading this, your daily choices are either building a fortress around your neurons or tearing down the walls that protect your memories. The most terrifying discovery is that the number one habit on this list can shrink your hippocampus, the memory center of your brain, by up to 1.8% per year. And researchers found that people who engage in this behavior regularly show brain scans identical to someone 10 years older. What makes this even more alarming is that the damage begins accumulating silently, often decades before any symptoms appear, creating a ticking bomb inside your skull that you can't see or feel until it's potentially too late. You can find all research and medical studies in the description below if you'd like to dive deeper after watching. Before we begin, tell us in the comments now your age and where you're watching us from. We're reading and replying to every single comment, so drop your comments below. Now, without any further ado, let's get started. Number 6. Poor sleep quality. Your brain has a waste removal system called the glymphatic system that works primarily while you sleep, flushing out toxic proteins like beta-amyloid that accumulate during your waking hours. When you consistently get poor quality sleep, or less than 7 hours per night, these toxic proteins build up in your brain, like garbage piling up on the streets during a sanitation strike. A study from the University of California, Berkeley, examined the sleep patterns and brain scans of 26 adults and found that just 1 night of sleep deprivation increased beta-amyloid accumulation by 5% in critical brain regions. The researchers discovered that the less deep sleep participants got, the more toxic protein clustered in their brain tissue, particularly in areas vulnerable to Alzheimer's disease. Over time, chronic sleep deprivation creates a vicious cycle where the accumulation of these proteins makes it even harder to achieve deep restorative sleep. The National Institutes of Health followed 7,959 people over 25 years and found that those who consistently slept less than 6 hours per night had a 30% higher risk of developing dementia compared to people who slept 7 hours. Sleep fragmentation, where you wake up multiple times throughout the night, even briefly, is equally damaging because it prevents your brain from entering the deep sleep stages necessary for memory consolidation and cellular repair. During deep sleep, your brain cells actually shrink by up to 60%, allowing cerebrospinal fluid to flow through and wash away metabolic waste products that accumulated during the day. Without adequate deep sleep, this cleaning process is incomplete, and the toxic buildup accelerates neurodegeneration. Sleep apnea, a condition where breathing repeatedly stops during sleep, is particularly dangerous because it combines poor sleep quality with oxygen deprivation, creating a perfect storm for cognitive decline. Studies show that untreated sleep apnea increases dementia risk by 85%, and brain imaging reveals significant shrinkage in areas responsible for memory and decision-making. The connection between sleep and dementia is so strong that researchers can now predict cognitive decline risk simply by measuring someone's sleep quality and duration over time. Now, let's talk about something that happens when you're awake but not really present. Number 5. Chronic social isolation. Human brains evolved to be social, and meaningful social interaction provides constant cognitive stimulation that keeps your neural networks active and resilient. When you spend extended periods isolated from others, your brain literally begins to atrophy in regions responsible for memory, emotional regulation, and complex thinking. A landmark study published in the Journals of Gerontology followed 12,030 adults over 50 for a decade and discovered that those who reported feeling lonely had a 40% increased risk of developing dementia, regardless of their actual social contact frequency. The key finding was that perceived loneliness, not just physical isolation, triggers inflammatory responses in the brain that damage neurons and accelerate cognitive decline. Researchers from Florida State University analyzed data from 12,000 participants and found that socially isolated individuals experienced cognitive decline at twice the rate of people with regular social engagement. The mechanism behind this is fascinating because social interaction requires your brain to perform multiple complex tasks simultaneously, including reading facial expressions, processing verbal and nonverbal cues, formulating responses, and managing emotional reactions. Each conversation is essentially a workout for your prefrontal cortex and hippocampus, strengthening neural connections and promoting neuroplasticity. Social isolation also increases cortisol levels, the stress hormone, that in chronic elevation literally kills brain cells in the hippocampus, where memories are formed. A study in the American Journal of Epidemiology tracked 2,249 women and found that those with the smallest social networks had 26% more cognitive decline over 4 years compared to women with larger social circles. Even more concerning, socially isolated individuals are more likely to engage in other dementia-accelerating behaviors, like physical inactivity, poor diet, and inadequate sleep, creating a cascade of risk factors. The loneliness epidemic has become so severe that some researchers now consider it as dangerous to your brain health as smoking 15 cigarettes per day. What's particularly heartbreaking is that many people don't realize they're lonely until the isolation has already begun causing measurable brain damage, and by that point, the social anxiety and cognitive decline make it even harder to reconnect with others. But there's something you might be eating every day that's even worse. Number 4, high sugar and processed food consumption. Your brain is an incredibly energy-demanding organ that consumes about 20% of your body's total glucose supply. But when you flood it with excessive sugar and processed foods, you're essentially poisoning the very cells that depend on proper fuel. Consistently high blood sugar levels trigger a process called glycation, where sugar molecules bind to proteins in your brain, forming advanced glycation end products that damage neurons and blood vessels. A study from Columbia University Medical Center followed 2,226 participants and discovered that those with the highest blood sugar levels experienced hippocampal shrinkage at a rate 6 to 10% faster than those with normal glucose levels. The researchers found this effect even in people without diabetes, meaning you don't need to be diabetic for sugar to damage your brain. Processed foods containing trans fats, excessive sodium, and artificial additives create chronic inflammation throughout your body, but your brain is particularly vulnerable because neuroinflammation directly kills neurons and prevents the formation of new neural connections. A Rush University Memory and Aging project examined the diets of 923 participants over 5 years and found that those who most closely followed a Western diet, high in red meat, processed foods, and refined sugars, had cognitive abilities equivalent to someone 5.8 years older. Ultra-processed foods, which now make up nearly 60% of the average American diet, are particularly devastating because they lack the nutrients your brain needs to produce neurotransmitters and maintain myelin, the protective coating around nerve fibers. Studies show that people who consume the most ultra-processed foods have a 28% faster rate of cognitive decline compared to those eating primarily whole foods. High sugar intake also promotes insulin resistance in the brain, a condition some researchers now call type 3 diabetes, where brain cells become unable to effectively use glucose for energy despite its abundance in the bloodstream. A study in Diabetologia followed 5,189 people over 10 years and found that those with type 2 diabetes had a 60% increased risk of developing dementia, with the risk increasing proportionally to how poorly their blood sugar was. The damage from poor diet is cumulative and insidious, with each sugary snack and processed meal contributing to a gradual deterioration that manifests years or decades later as memory problems and confusion. The next habit might surprise you because it involves something missing. Number 3, physical inactivity. When you sit for extended periods without regular physical activity, you're depriving your brain of one of the most powerful protective factors against neurodegeneration. Exercise increases blood flow to your brain, delivering oxygen and nutrients while removing waste products, but it also triggers the release of brain-derived neurotropic factor, a protein that acts like fertilizer for your neurons, promoting growth, survival, and the formation of new connections. A comprehensive study published in Neurology followed 876 participants over 30 years and found that those with low cardiovascular fitness in midlife had significantly smaller brain volumes decades later, with their brains appearing to have aged an additional 10 years. The researchers discovered that every increase in heart rate and blood pressure during a low-intensity exercise test was associated with smaller brain volume 2 decades later, indicating that poor fitness accelerates brain atrophy. Physical inactivity also reduces neurogenesis, the birth of new neurons in the hippocampus, which is essential for forming new memories and maintaining cognitive flexibility throughout life. A study from the University of British Columbia found that regular aerobic exercise increases the size of the hippocampus by up to 2%, effectively reversing age-related volume loss by 1 to 2 years. The minimum effective dose appears to be 150 minutes of moderate intensity exercise per week, which is just 30 minutes 5 days a week, yet fewer than 25% of adults meet this threshold. Exercise also reduces insulin resistance, lowers inflammation, promotes the growth of new blood vessels in the brain, and improves sleep quality, creating multiple protective pathways against cognitive decline. Resistance training is equally important because it triggers the release of irisin, a hormone that crosses the blood-brain barrier and activates genes involved in learning and memory. A study of 100 adults with mild cognitive impairment found that those who engaged in resistance training twice weekly for 6 months showed significant improvements in executive function and reduced brain atrophy compared to the control group. The beauty of exercise is that it's never too late to start, with studies showing cognitive benefits even when people begin exercising in their 60s and 70s, though starting earlier provides exponentially greater protection. Think of exercise as a daily insurance policy for your brain, where each workout deposits protection into an account that pays dividends in preserved memory and independence as you age. But even if you exercise, this next habit can undo all those benefits. Number 2, chronic stress and elevated cortisol. When you experience constant stress without adequate recovery, your body maintains elevated levels of cortisol, a hormone that in acute situations helps you survive immediate threats, but in chronic elevation systematically destroys brain tissue. Cortisol directly damages the hippocampus by killing existing neurons, preventing the formation of new ones, and causing the dendrites, the branch-like structures that allow neurons to communicate, to shrink and retract. A Yale University study used brain imaging to examine 103 participants and found that those who reported the highest stress levels had a 20% smaller hippocampal volume compared to low-stress individuals, even after controlling for age and other factors. The mechanism is brutally straightforward because chronic cortisol exposure overstimulates glutamate receptors on neurons, causing an influx of calcium that triggers cell death in a process called excitotoxicity. Stress also accelerates the shortening of telomeres, the protective caps on the ends of your chromosomes that determine cellular aging, with chronic stress essentially causing your brain cells to age faster at the molecular level. Research from the University of California, San Francisco found that women with the highest stress levels had telomeres equivalent to someone 10 years older. Chronic stress impairs the prefrontal cortex, the brain region responsible for decision-making, impulse control, and emotional regulation, creating a vicious cycle where stress damages your ability to manage stress effectively. A longitudinal study published in BMJ followed 6,895 civil servants over 14 years and discovered that those with persistent elevated cortisol levels had significantly worse memory and cognitive function, with brain scans showing reduced brain volume. The researchers found that high cortisol was associated with a 14% reduction in total brain volume, with the most severe damage in regions critical for memory formation. And now for the most devastating habit of all. Number 1. Heavy alcohol consumption. Alcohol is a neurotoxin that directly kills brain cells, and even moderate drinking causes measurable brain damage that accumulates over time into significant cognitive impairment and dramatically increased dementia risk. When you drink alcohol, it crosses the blood-brain barrier within minutes and begins interfering with neurotransmitter systems, disrupting communication between neurons and triggering inflammatory cascades that damage brain tissue. The landmark Whitehall 2 study from Oxford University analyzed brain scans and cognitive tests from 550 participants over 30 years and made a shocking discovery. People consuming just 14 to 21 drinks per week had 3 times the risk of hippocampal atrophy compared to non-drinkers. And even those drinking moderately showed accelerated cognitive decline. The study found that for every additional drink consumed per day, the risk of brain atrophy increased proportionally, with no safe threshold identified. A massive meta-analysis published in the Lancet examined data from over 1 million adults and found that heavy drinking, defined as more than 21 drinks weekly, increases dementia risk by 170%, while even moderate drinking of 7 to 14 drinks weekly increases risk by 17%. Alcohol damages your brain through multiple pathways simultaneously, including direct neurotoxicity, thiamine deficiency, which causes Wernicke-Korsakoff syndrome and permanent memory loss, increased inflammation, disrupted sleep architecture, elevated homocysteine levels that damage blood vessels, and impaired neurogenesis in the hippocampus. A study from the University of Pennsylvania used brain imaging on 36,638 adults and discovered that going from 0 to 1 drink per day was associated with the equivalent of 2 years of brain aging, and going from 1 to 2 drinks per day represented an additional 2 years of aging. The researchers found that brain volume decreased proportionally with alcohol consumption, with the effect accelerating as consumption increased. Binge drinking is particularly destructive because it causes acute swelling in the brain, damages the integrity of white matter tracts that connect different brain regions, and triggers the death of newly formed neurons in the hippocampus. Even after people quit drinking, some of the damage persists permanently, particularly in executive function and working memory, though the brain does show remarkable recovery in the first year of abstinence. The French National Hospital database analyzed 57 million adults and found that alcohol use disorders were the strongest modifiable risk factor for early onset dementia, being responsible for 38.9% of all cases in people under 65. What makes alcohol particularly insidious is its social acceptability and cultural promotion, with millions of people consuming brain-damaging amounts while believing they're drinking moderately or safely. The wine industry has pushed narratives about health benefits from moderate drinking, but the most rigorous recent studies show that any amount of alcohol causes some degree of brain damage, and the supposed cardiovascular benefits are vastly outweighed by the neurological harm. Every drink you consume is making a withdrawal from your cognitive reserve, the buffer of brain health that determines when and if dementia symptoms will appear. And for heavy drinkers, that reserve can be depleted decades earlier than it would naturally occur. Your brain is the most complex structure in the known universe, containing 86 billion neurons and trillions of connections that create everything you think, feel, and remember. The 6 habits we've discussed don't just increase your dementia risk in isolation, they compound and accelerate each other, creating a cascade of neurodegeneration that can begin decades before symptoms appear. The encouraging news is that your brain has remarkable plasticity and resilience, and research consistently shows that addressing these habits, even in midlife, can significantly reduce your risk and potentially reverse some early damage. Every positive choice you make today, whether it's going for a walk, calling a friend, eating a nutrient-dense meal, managing your stress, improving your sleep, or reducing alcohol consumption, is an investment in your cognitive future. The question isn't whether you'll age, it's whether you'll age with your memories, personality, and independence intact, or lose yourself piece by piece to a disease that was largely preventable. The data is clear and the science is unambiguous, but knowledge without action is worthless, and the time to start protecting your brain is right now, not tomorrow or next week or when symptoms appear. If you found this information valuable and want to protect not just your brain, but your entire future, make sure to subscribe to our channel and hit the notification bell so you never miss content that could change your life. Share this video with someone you care about, because protecting our brains is something we should all be doing together. And share with us your experiences and opinions in the comments below. We love to hear them.